Welcome to Lecture 2 on Fluids and Temperature. This lecture deals with two equations. F is equal to PA, which F is force. We've had that before. P is pressure, and A is area. Some books may have this, P is equal to F over A, but to make it easier to write, I'm using this one. Force is in newtons or pounds, area, something squared, and pressure is a force over an area. You notice I've got pounds in here besides the metric, newtons per square meter or pascals. So these can be mixed and match anyway as long as you have a force unit over an area unit. Here's one. This is mainly used for liquids at depth where P sub T, this is not PT, this is P sub T, is your total pressure. And this one you have to be more specific, it's in pascals. Atmospheric pressure is 101.3 kilopascals, and in these you're going to have to use 101/300 because this is in pascals and this is in pascals, and we know from our math teacher we have to keep all of the units the same. D is density, and this has to be in kilograms per cubic meter. G is 10 or 9.8 depending on your instructor, and H is height. Technically it's height, but we can also use depth of the water. And like I said in the last lecture, some of y'all may be using rho as the symbol for density. So let's kind of look at what we have today. It says, what is the pressure exerted by a 40 kilogram mass? Okay, there's mass, and this is an area. So we know that force is equal to pressure times area. Well, I have to kind of go back to Newton. Okay, so remember, we have a mass, but I need a force. So I go 40, and you've got to get it to newtons, multiply it by 10. Pressure and the area is 0.45. Okay, now this will get into our pressure units of newtons per square meter. So if you see a mass, need to change it to newtons so you can get it going. Then that way, or this could be in pascals depending on how your instructor tells you, but this is the easiest way to write this. Here's one. What is the total pressure? Okay, we want total pressure. These kind of clue you in. So if you see total pressure, absolute pressure, okay, a 60 kilogram swimmer, 10 meters below, so there's our height, technically negative height. There's our density. So if you see a density in here with pressure, you're going to use this one. It's atmospheres plus dGH, or you might use the rho. And it says, what is the total pressure? That's P sub T, not P times T. And I'm going to use 101/300. Okay, remember that has to be in pascals. Let's put a plus there. The density is 101, or 1010. G is 10, and 10 below. And so my total pressure will be in pascals. So it's a simple plug and chug, but just remember that your atmospheric pressure, you need to change your kilopascals to pascals. Here's one, and so if you're in submarine design or something that's going to go deep in the ocean, you're going to have to use this equation because you're going to have to figure out how deep do I need, can I let it go down before things happen. Okay, it says it cannot exceed this in total pressure. So that's 2.5 times 10 to the 6, okay. Remember on the surface it has atmospheric pressure, and then the density, since that's 101 or 100, or that, let's try this again, 1025 times 10, there's G, and H And then it's just simple math problem, so we can find the meter. So when if you're selling, it says, okay, this is the deepest you better go, and then go from there. Let's do one more so you can see on this, and this one right here, the mass of the swimmer or the object does not make any difference in the pressure, just your water depth or your liquid depth. Okay, here's what is the force. Okay, I have a pressure and an area, so F equals PA. Now you're probably thinking to yourself, do I need to convert this into newtons and meters or something like this? No, remember, pressure is a force over an area. So pressure is 3,000 and my area is 12. Remember, the square just goes with the units, not the number. And F, now you're probably thinking, what units? Force, area. So it'll be from there. So you can see these are pretty straightforward. If you see a density in here, you're going to use this one right here. Otherwise, pretty simple. Okay. There's more for you to work. If you do have any questions, feel free to contact your instructor or me.